Today we are going to study about RC circuits. So if a circuit has a capacitance and a resistor, it is called an RC circuit. So in the first case, let us we take this circuit and let's try to join this switch. And when we join this switch, then the battery, the capacitor and the resistor, they come in one circuit. So this can also be drawn like this. So they are equivalent when the switch is closed. So at time 0, because on this capacitor there will be no charge at time 0, so we say that the charge on the capacitor will be equal to 0. So if the charge on the capacitor is 0, it means that the potential drop at the capacitor will be 0. So it means that this entire potential will be, all of this potential will appear at the resistor. Okay, so this epsilon, it means will be delta V plus IR, the current through the resistor. Okay. So it will be 0 plus IR. So it means that this total potential will appear only at the resistor and it will not appear at the capacitor. Okay. So if the potential drop here is 0 and R is a constant, so because we know that R is a constant and this entire potential drop is only at a resistor, this means that this current will be the maximum current, because after this the charge will increase and there will be some potential drop. But initially the charge is 0 and potential drop is 0. Therefore this current cannot be greater than the current which is at this point. So we say that current should be equal to epsilon upon R, and this should be the maximum current in the circuit. And this is the maximum current. Okay, so then at any time t, suppose now that there is some charge on this capacitor, let us say because it is a positive terminal, this is a negative terminal, so we say it will be plus q here and minus q on this one, and a resistor. So at any time t there will be some current through this circuit, and due to this current there will be a charge created on the capacitor, and there will also be a potential drop due to this charge. And let us say that the potential drop on this capacitor is delta V. Also, let us also discuss what will happen at, I forgot to draw a battery, so here it should be a battery, plus and minus. So at infinite time you will have a charge on this capacitor which will be maximum charge. So this is the maximum charge on the capacitor. Okay. So when the charge is maximum on the capacitor, no more electrons will flow from the source of EMF to the capacitor. Okay. So no more electron flow will take place. So it means that the current in this case will be equal to 0. So if the current is 0, it means that the potential drop at the resistor will be 0 volts, because the potential drop here will be IR, and therefore because current is 0, so this will be equal to 0. The potential drop on the resistor will be 0. So it means that this potential will appear on the capacitor. So at this point we can say that because we know that delta V on the capacitor will be so in this case the potential drop is epsilon, charge is capital Q, and capacitance is C. So we can say that the total charge on the capacitor will be C epsilon. So this will be the maximum charge on the capacitor, okay, at infinite time. So we have to remember a few things from here, that when time is 0, there is 0 charge on the capacitor and the current is maximum, and when the time is infinite, current is 0, charge is maximum, okay. So now let's discuss this case in detail. When at any time t, let us discuss the second case in detail. When the time is t, the charge on capacitor is q. So by using Kirchhoff's second law, it states that the total change in potential is equal to 0 in a loop. So let's take this loop here, and so let's say that we are moving in a clockwise direction. So we are moving from minus to plus at the battery, so it will be plus epsilon, and we are moving from plus to minus, so it will be minus delta V on the capacitor. And here we are moving from plus to minus, so it will be minus IR. The potential drop at the resistor will be equal to 0. So we can also write it as, because the potential drop at the capacitor is given by Q upon C, and the current, actually this current will be the rate at which this charge is changing. Now this charge Q, it is not a constant, it's a variable, it's varying. Okay. So this current is also varying, and it depends on how much charge there is on the capacitor. So we can also write it as dq upon dt to R is equal to 0. Okay. So now in order to solve this equation, we'll take this, we'll make this expression divided into q and t, because it has a derivation in q and t. So the calculation will be something like this. Okay. So we can take the integration. Here the integration is on charge, and here the integration is on time. So because we are moving from charge 0 to charge q and time 0 to any time t, this integration turns out to be log of q minus c epsilon 0 to q will be equal to minus d upon rc after putting in these values. So it will be log of q minus c epsilon minus log of q, which will be equal to minus d upon rc. So let's try to solve this equation. It will be, I think I've made a mistake here. Here it should be C epsilon. So it will be log Q minus C epsilon divided by C epsilon is equal to minus D upon RC. Therefore, we can also write exponential minus t upon rc, and therefore it will be q minus c epsilon is equal to c epsilon minus t upon rc, or we can also write it as q is equal to c epsilon 1. I think I've missed a negative sign somewhere, so it will be 1 plus exponential minus t upon rc. Okay, so we need to have a negative c epsilon here because it will be minus c epsilon. So if it is negative, we get a negative here, and so if it is a negative here, you should get a negative here. Okay, so this will be the expression for the charge variation with the time and rc. We can also find out the current from here. Current will be equal to dq upon dt, so it will be c epsilon 0 minus 1 upon rc, derivative of this, the power of exponential, to minus t upon rc. So what we get from here is c epsilon divided by rc exponential minus t upon rc. So c will cancel with c, and it will be epsilon upon r exponential minus t upon rc. So this is how the current will vary. Now if we have to plot charge and current, we just need to see what will happen at various values of t. And I would just like to mention that this constant rc, it is called time constant of a RC circuit. And it is given by a symbol tau. So let's try to plot this function of q which varies with time and current which varies with time. So you know that current is epsilon upon r exponential minus t upon rc. So in order to solve it, we just need to see what will happen at various values of time. So let's say if time is 0, what will be the value of charge? Charge will be c epsilon 1 minus exponential minus 0 upon rc, so it will be 0. Okay, so if t is equal to rc, q will be equal to c epsilon 1 minus exponential minus 1, so it will be c epsilon 1 minus 1 upon e. So just put the value of e. And c epsilon is the maximum charge, and it will be 1 minus 1 upon, the value of exponential is around 2.7, and when you calculate it, what you get is 0.632 times of charge. Similarly, when time is infinite, charge will be equal to c epsilon 1 minus exponential minus infinity. 1 upon infinity will be 0, so it will be c epsilon, which will be equal to the maximum charge. So if I have to plot it now, then it will look like will these values of charge when plotted look like. So if it is time versus q, so at time 0 charge is 0, so we can plot it here. At time rc, charge is some value of the maximum charge, and at infinite time charge is a constant. Okay, so at infinite time it means the charge will be a constant value, and this constant value should be equal to capital Q. and it will be an exponential function. Okay, and time is equal to RC, and this is time is equal to 0. And at time is equal to RC, the charge is 0.632 times of the total charge. Okay. In the similar manner, we can also plot current. So if we try to find out the value of current, which is given by this expression, while charge is given by this expression. So if we try to find out how current will vary, let's try to make a similar chart that if time is 0, current will be equal to exponential upon epsilon upon r exponential 0, which will be equal to, which is the maximum current at time 0. At time is equal to RC, current will be epsilon upon r exponential -1. So it will be I maximum upon 2.7, so it comes out to be 0.368 I maximum. Okay, and then at t is equal to infinity, current will be minus infinity will be 0, so it will be 0. Okay, so now if I have to plot current versus time, then at infinite time the current will be 0. Okay, so it will be somewhere here, it will be 0. And at time 0 it is some maximum value, so it will behave something like this. Okay, it's exponential graph, so it will decrease exponentially. Okay. So this is some maximum value of current at time 0, and at time RC current will be 0.6368 of I maximum. Okay, this is how the current will look like.